Hello, my name is Can Matuca. I'm recording this for object-oriented course final assignment. You want us to shape a class that helps us to find the shortest straight, or in some cases shortest network connections. I wrote the code for the shortest path between these. This is why you see the most of the variables and lists or definitions named a city or distance. So the first we want to create an initialize definition, which we would store the connections from nodes to other nodes with values using dictionary, and the other definition we want to add is to adding cities and paths, which we will be able to use it outside of the class. So the add city function takes arguments name, which is going to represent the cities, and the add path functions gets three arguments: distance, starting, and ending cities. This is the algorithm to find shortest distance. It's a little bit complicated, but I will try to explain it anyways. So the first one, we want to define all distances as infinite. This is definition of infinite, and this is for the every object in connections. So once we define distances infinite, we want to define the starting point as 0, because we are already there. So after we do that, we define all connections, all cities that all cities like they do not have any connection to other cities, because we will change it later on here. So this is the term we are going to use to evaluate if the distance to check which distance is minimum. So first we set the distance as 0, and we get the start, which is starting city A in our example. So while priority queue has elements inside, it checks which can I say that it will check for the zeroth index of this, which is the distance, and it will give us the minimum of the current distances. In first loop, it is only A, so it's 0 for now. And after it does that, it removes the current distance and current city, because we already had check of it. So after we get that, it checks if current distance is greater than the distances, all of distances from the other cities to current city, and if it's greater, it ends, because it means that it already checked the others all the ways possible. So it is it does not work here. However, in the first step, it doesn't end. It looks for every neighbor distances, which if a neighbor distance is greater than all the distance, it looks for the every cities. How can I say that? It looks for the every distance that comes from other cities to our current city, and it it will add the distance to our current distance, which is 0 now. And after it does that, it checks if our current distance, I mean not the current distance, but the distance at this time is greater than any of the distance that comes from other cities from of a neighbor. And if it is smaller, then it will become the new distance because we find better way. And since we find better way, we define the neighbor as our new. We define the neighbor as our new static point. So this is why. Sorry, my brother interrupted. So after we do that, we append this priority. We append the ending distance and the neighbor to priority queue list, and after we append it, it will look up the next step. So let's say we find B was the ending point. Sorry. Let's say we find C has better connection than its direct connections. Then it will repeats the processes until it finds the best way. And the function returns the distances and previous connection. So as you can understand, this does not have any visited status because it already does it here. It does not necessarily use any list or other things. So this is the test sample that you wanted us to use in the video. First, we create an object named graph to remember it easier. So after we do that, we create sts using @st function definition, and after we do that, we should define the all paths possible, since in the video all paths have the two side connections, so we can go both ways. And as it's in the video, we define the starting state as A and we define the ending state as B. So after we do that, we should call the Djiktras function, which starts the input, and it will give us the distances, all the distances and previous connections, which we are going to use it later in the definitions. And this is only to find shortest distance to end state, which and this loop is to find the path. First, we create a empty list, and we define the current state as end state. And while current state have an element, have anything inside of it, it will replace the zeroth index of the path list as the current state, which first it will insert the end state to the zeroth index, and after it does that, current state changes the previous connection, which means it becomes the one that before the end state. By doing that, end state now becomes the first index, and the current state now becomes the next current state is becomes the zeroth index, and it repeats the process until there is no element inside of it. And this one is at the arrow and a line between the element of path to make the outcome looks better. So as you can see, This is the just print function. Those are placeholders, which are going to which we are going to need to understand the outcome. So as you can see, my functions only gives us the path and the shortest distance from state A to state B, and we can change that in case we want. It will give us the correct option. So let's say we want to go from A to C, and in that case it will give us the tree which is directly the path from A to C. Thank you for watching.